X-rays, properties of X-rays, dangers of X-rays. In this topic, we will discuss the following subtopics: production of X-rays, X-rays tube, energy changes in an X-ray tube, types of X-rays, properties of X-rays, dangers of X-rays and precautions, and uses of X-rays. Introduction. X-rays are important in our day-to-day life. In medicine, they aid in diagnosis of ailments, and in industry, they assist in detecting cracks and flaws in finished products. Parts of the X-ray tube. The following animation shows the working of the parts of the X-ray tube. Place the mouse over the various parts to get the corresponding
Heat
explanations.
Shield. It blocks stray cooling fins. Conduct heat away into the air to protect the target from melting. The tungsten target. It is made up of a metal with a high atomic number and a high melting point to avoid melting, since most of the energy of the electrons is converted into heat energy. About 0.5% is converted into X-rays. The heater circuit has a low voltage. It is for heating the cathode so that the electrons are generated. The cathode is concave in shape so as to produce a parallel beam of electrons. Accelerating voltage. The heater circuit has a low voltage. It is for heating the cathode so that the electrons are generated. The cathode is concave in shape so as to produce a parallel beam of electrons. The heater circuit has a low voltage. It is for heating the cathode so that the electrons are generated. The cathode is concave in shape so as to produce a parallel beam of electrons. The heater circuit has a low voltage. It is for heating the cathode so that the electrons are generated.
Production of X-rays. X-rays are produced when fast-moving electrons or cathode rays hit a target, which is normally a heavy metal, for example, tungsten. The animation below shows the production of X-rays. Click on the play button and make your observations. Observation. When the heater circuit is switched on, the cathode glows red hot and a stream of electrons is produced. These electrons hit the target, producing a stream of X-rays. Explanation. These electrons are produced by thermionic emission and attracted to the tungsten anode or target. Upon hitting the target, most of their kinetic energy is converted into heat and a small percentage into X-rays. Energy changes in the X-ray tube. At the heater circuit, electric current is used to heat the cathode, transforming the electrical energy into heat energy. The electrons gain enough energy to leave the cathode. At this point, the heat energy is transformed into kinetic energy of the electrons. The electrons are then made to move faster by the high accelerating voltage between the anode and the cathode. On hitting the anode, the kinetic energy of the electrons is transformed into heat and X-rays. Types of X-rays. There are two types of X-rays, namely hard X-rays and soft X-rays. When high accelerating voltage is used, the electrons move with a very high velocity, producing X-rays with a very short wavelength. These are referred to as hard X-rays. They have high velocity and hence high penetrating power. They penetrate flesh and are stopped by bones and other materials of high density. When a low accelerating voltage is used, the electrons move with a low velocity, producing X-rays with long wavelengths. These are referred to as soft X-rays. They have low velocity, hence low penetrating power. They can penetrate flesh. Properties of X-rays. The following types of X-rays. Click on the play button to make your observations. Properties of X-rays. The following are the properties of X-rays. They are not deflected by either magnetic or electric field. Click on the switch on the animation below to generate X-rays. Then click on the word electric field and later on the word magnetic field button and observe what happens on the X-rays as they move through the said fields. Observation. The X-rays are observed to pass through both magnetic and electric field without being deflected. Explanation. X-rays are not charged, hence they are not deflected by either a magnetic or an electric field. Dangers of X-rays. Overexposure to X-rays can lead to killing of body cells and gene mutations. This is the alteration of the gene structure which may lead to disorder or deformities like skin cancer in the body. Precautions. The X-ray tube is covered with lead shielding to protect the operator from exposure to the rays. The machines are operated in rooms that have concrete walls to absorb any leakages. Uses of X-rays. The following are some of the uses of X-rays. X-rays are used to detect fractures in bones. Hard X-rays can be carefully directed to destroy cancerous cells in the body. Click on the play button to X-rays are used for detecting flaws or cracks on metal castings. Click on the play button of the following animation and observe how this is done.